Okay, here's warm up 9.7. So, first problem, we're solving for this thing that's called theta, right? It's a missing angle. You could just put a variable there, but we usually use theta, okay? So, some people might look at this and say, hey, wait a second, that's a 5, 12, 13 triangle. That's a Pythagorean triple. So, this bottom side is going to be 12, which you could also find with the Pythagorean theorem. And that's great, and it's true, but that's not telling me the measure of that angle. I'm looking for the measure of this angle, okay? So I want to set up, I want to use SOHCAHTOA here. So I want to put myself at the acute angle that's marked. So I'm going to be down here. Then I'm thinking what parts of the triangle are, what sides of the triangle are marked. So I've got the hypotenuse, and then I've got one of the legs, and this is the opposite leg here, right? So then I'm thinking SOHCAHTOA. Need to choose the right piece. I want to choose the one that uses opposite and hypotenuse. That would be sine. So I'm going to set up a sine function here. So sine of, and I want to say where I am. I don't know the measure of that angle. I don't know the name of it either, but it's where the theta is. So sine of theta is going to equal, and then opposite would be 5, hypotenuse would be 13. So opposite over hypotenuse, 5 over 13. Okay? So I've got it here, and now what I want to do is isolate theta. You can't just divide by sine. Sine itself is not a number. That would be like dividing by square root. That doesn't really make sense, right? So what I need to do is get the theta by itself. There's a little maneuver you can pull where you can switch the position of these two things, okay? So I'm just going to write this same function, except I'm going to put the 5/13 here, and I'm going to put the theta here, okay? Now the only thing I need to do to make this work, if you want to switch those, is put a little -1 exponent in that position. Don't put it out here, put it after the sign. So this means the inverse sign of 5/13. You might sometimes see arc sine of 5/13, which means the same thing, okay? And then this is something that I can put into my calculator. The theta is isolated. So if you have a sine key on your calculator, you're also going to have an inverse sine key. So if you look on my calculator, it's probably hard to see here. Let me see if I can show you. But there's sine, and right above it says sine to the -1st. So what I'm going to do on my calculator is hit second and then sine. That's the way it works on most scientific calculators. Sometimes you might have to put the number in first. On mine, you put that in first, and then don't try raising it to the -1st. That's we want to use inverse sine. Okay, and then I'm putting in 5/13 like that as the contents. Some calculators you might need to find 5/13 first, then do the inverse sine of 0.3846. Okay, but mine I just put it in as is. I'm in degree mode because I want this measure in degrees. You could do it in radians, but for now we're just doing degrees. So if you got a different number, check if you're in degree or radian mode. I'm in degree mode. So that means this is going to be about 22.62 degrees. That's the measure of that angle in degrees. Okay. All right, next up, we're going to write cosine of 37 degrees in terms of sine. So I'm going to write a sine function that is equal to this. Okay, so the cosine of 37 degrees is going to equal the sine of something, and I need to figure out what that something is. And here's how we can do it. They're going to be complements. So I need to find the complement of 37. So 37 plus something is going to equal 90. So you can just kind of think through it like that. Or to write a little equation, I want to find, what plus 37 equals 90? Well, I can do 90 minus 37. And that's going to come out to 53 degrees. So sine of 53 degrees should be equal to the cosine of 37 degrees. And, if you're not sure, you could test it out. Let's see. Cosine of 37 degrees, about 0.7986. And then sine of 53 degrees. Hey, look at that there. So it's really easy to test if you got the correct answer. Just put both the original and your new one in. Okay, but if you just change it from cosine to sine, then you just use the complement. Okay, all right, next up, the angle depression from a kite to the place that it is tied to the ground is 64 degrees. I'm going to stop right there and just draw a picture based on that first sentence. I've got a kite. Okay, there's my kite. It's tied to the ground. Okay, And then it says the angle of depression from the kite to the place that it's tied on the ground is 64 degrees. And this is going to get a little tricky here, okay? So we are going to have a triangle like this because they talk about the height of the kite in the next sentence. So the height of the kite is 50 feet, okay? So that's great. But a lot of times I'll see people put the 64 right here, and that's actually incorrect, okay? That's not the angle of depression from the kite to the ground, to the place where it's tied to the ground, okay? If you think about the kite looking straight forward, it would be looking straight forward like that, and let's say the kite then looked down to the ground where it's tied to the ground, it would shift its eyes down like that, okay? So the angle of depression, you have to think about, like, a lot of times there's like a pilot in a helicopter looking down at something, it would be an angle of depression. So the 64 degrees is actually going to go there, okay? Now, we're asked to find the length of the string, so that's going to be this, okay? Now we got a little problem because that 64 degrees isn't in the right triangle that I have. But there's two pretty good solutions to that. One, these two angles are going to form a right angle together. So this would be the complement of 64. So that's totally fine. You can do 90 minus 64 to get this angle. Okay. Another way you can do it, and what I usually do, we're making an assumption too on this problem that the ground is horizontal, that the ground is flat. If that's the case, then we've got these parallel lines. This would be a transversal, and that means that this angle is going to be congruent to that one by alternate interior angles theorem. So if this is 64 degrees, this is 64 degrees, and now we can do SOHCAHTOA, okay? But if you found this angle instead, that's fine. You could do SOHCAHTOA from there. So for me, when I set up my SOHCAHTOA, I'm going to be at the 64 degree angle, so I'm down here where it's tied to the ground, okay? And then 50 would be the opposite leg, and x is the hypotenuse. Okay, so I'm just thinking SOHCAHTOA, well, that would be the sine part of SOHCAHTOA, right? SOHCAHTOA, the only part that uses opposite and hypotenuse is sine, so I'm thinking, okay, sine of 64 degrees, I want to indicate where I am, and then opposite over hypotenuse, 50 over x. Okay? Now you can use my little shortcut when you've got a number that's equal to a fraction with a variable in the denominator. Some people are going to try to multiply both sides by 50, but that's not going to isolate the x here. But what you can do is use my shortcut, just switch the position of those things. I call it the incredible switch. Or another option, multiply both sides by x, then divide by sine of 64 degrees. And where you'll end up is right here, where I did with the incredible switch. Okay? And then it's calculator time. So some calculators might have to figure out what sine of 64 is first, and then do 50 divided by that. My calculator, I can just type it in like this. Make sure you're in degree mode again because we're dealing in degrees. So I've got 55.63. We're going to the nearest hundredth of a foot. So it's that many feet. Okay, that's the end of the warm-up, and I'll see you next time.